Alright folks, so in the last video we talked a little bit about introducing the linear regression equation, which we can see right here. Again, the linear regression equation is designed to produce a line of best fit. It involves using two of what are called regression coefficients, the y-intercept, or A, which is the starting point of the line, what the expected or predicted y-score is if x was a 0, because it's a starting point of the line. B tells us the slope, or the angle that that regression line takes, and again it's intended to spit out y-hats, which are predicted or estimated values of y for a specific value of x that you input into that equation. Before we talk a little bit about how this works in practice, let's break down why it's so important to know those two regression coefficients, the y-intercept and the slope, A and B. So here's the logic. Let's say that all we knew about a regression line was the A, the y-intercept, where the line starts. Let's say it starts right about here. Problem is, of course, is that there's an awful lot of different regression lines that all could have the same starting point. You could have lines with upward slopes. I'm trying not to knock this down. Sharp upward slopes, flatter slopes. It could be perfectly flat. It could be downward slopes. You get the idea. There's lots and lots and lots and lots of different regression lines that all have exactly the same starting point. Let's say instead that you only knew the slope. You didn't know where the line started, but you knew what angle it took, what slope that it had. So you knew the slope looked something like that. Problem with that, of course, is that lots of different lines with lots of different starting points can all have exactly the same slope. These all have the same slope, or at least we're pretending that despite my awful writing that they do. So basically, if all you knew was A, or if all you knew was B, there'd be close to an infinite number of lines that all fit those criteria. But when we know both of them together, where the line starts and what angle it takes from that point, there's only one possible line that would fit both of those criteria. So just knowing those two basic pieces of information, again, it pins down what the line is. It isolates it, and there's only one possible regression line that would have both the same starting point and the same slope. So that's a little bit of the logic behind that. Now let's look at some examples. First, we'll look at some examples of some data that we'll plug in, and then in the next video we'll delve into actually calculating it. So let's start with a really simple example. Let's say that there is a tennis club that maybe you're interested in joining, and you're trying to figure out how much it will cost you. Well, they provide you some basic pricing information. They say, okay, it costs you $5 an hour for lessons once you join, but there's also an annual fee of $25. If you're trying to figure out how much money you would pay for an annual membership, you can actually plug those values into our regression equation here and get a predicted y. And in this case, y is how much you're going to pay. So first, our slope is how much does the cost go up every time our x goes up. And in this case, our x is how many hours of lessons that you would be taking. So however many hours of lessons you'll be taking, they're $5 each. So every time x goes up by 1, meaning you take another hour of lessons, your total cost will increase by $5. Pretty straightforward, right? We also have the starting point. If x is 0, if you don't take any lessons at all, you still got your annual fee here of $25. So you know that your starting point is 25. If x is 0, you know that y is 25. It costs $25 a year if you take no lessons at all. So $25 a year with no lessons at all, but for every hour of lessons you take, that cost goes up by $5. So here's what our equation would look like. Y hat equals 5 times x, and x is whatever number of hours you intend to take, plus your starting point, the $25 you pay just to join the club. So you could plug in any number of hours of lessons that you could take into there and get your predicted y, how much you expect it to cost. So what would the predicted cost be for someone who takes 10 hours of lessons? Well, say, okay, the lessons are $5 an hour. There are 10 hours there, so 5 times 10, it's $50 for the lessons, plus $25 for the annual fee, and it's a $75 expense. It's going to cost me $75 if I take 10 hours of lessons. What if I took 30 hours of lessons? What if I did it more often? Well, okay, they're $5 a piece. 5 times 30 is $150. We add that to 25. It's going to cost $175 for the year. What if I take 100 hours of lessons? I'm really into it and I want to take a lot of lessons. Well, 100 times 5, so $5 an hour. 100 times 5 is $500 for the lessons, plus $25 for the fee. Your predicted Y is now 525. All of those are pretty intuitive, pretty basic to calculate. Every single one of those is a predicted Y, a predicted expense, where we're plugging in specific values of X, and X is the number of lessons, hours of lessons that we take. We can visualize this in terms of what it looks like as a regression line as well. So here's that regression line. Notice again we have A locked in. It starts at 25. That's the starting point. When X is 0, we pay 25. And every time X goes up by 1, Y goes up by $5. So we can look here and you can even visualize how this equation works. If there's 10 hours of lessons being taken, okay, we go up here. Where does 10 hours meet with that line? Well, that corresponds with a Y of 75, so it would cost $75. If I take 30 hours of lessons, okay, that meets that regression line up here. What's the Y that matches with that? $175. And 100 hours, of course, is way off in the distance. For the simplicity's sake, we left that off of the chart. So you can use the line to visually represent that relationship. And you can even use it if you're precise enough to make predictions. But ultimately, we're going to want to make those predictions mathematically. So that's how this works in terms of a simple example where we know the slope and we know the y-intercept. What we don't know, though, is how do we calculate A and B, the y-intercept and the slope, from scratch, where we're starting with some raw data and we need to figure out what those two coefficients are. That's going to be the focus of our next video. So, see you there.